All right, so we're going to begin our unit on exponential functions. We're going to take a look at it in all kinds of situations, from a table into words, into equations, into graphs, and also into patterns. So let's take a look at what's happening. In hour 0, I have 3 bacteria. I don't even know if this is bacteria, but those of you in bio can help me out. I have 3 bacteria, and I'm going to go ahead and just circle it like this. So I'm going to say I have one group of 3. What happens in hour 2? Instead of having one group of 3, I now have what? 2 groups of 3. Okay, so what happens in hour 2? Instead of having 2 groups of 3, I now have 4 groups of 3. So my question to you is, what is going to happen in hour 3? So pause the video real quick and see if you can draw it. And again, you can just use dots. So that's a group right there. Okay, you can use dots to represent the bacteria. Pause the video and see if you can do it. All right, so the pattern looks like it goes 1, then it becomes 2, then it becomes 4. So if it keeps following this pattern, it is doubling. So instead of me having 4, I'm now going to have 8. So there's the 4 from that, but I'm going to double it to 8. And if this pattern continues, what will be in hour 4? Well, it's going to double from 8 to what? 16. 1, 2, 3, 4. That's 8, and then another one. 4, 1, 2, 3, 4. Okay, and we can just put those 3 dots in there. And then in hour 5, what is it going to do again? It's going to double. So the pattern in this exponential function is that it doubles each time. So let's go ahead and fill out the table. So in hour 0, I had how many? 3 bacteria, right? 3 little circles or whatever. In hour 1, instead of having one group of 3, I have 2 groups of 3. And if you want to count them, you can. It's going to be 2 groups of 3, which is 6. In hour 4, I have 4 groups of 3, where we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But it's just faster to go through multiplication. In hour 3, I'm going to double what I have. So I go from 12 to 24. In hour 4, I'm going to double what I have. So I go from 24 to 48. In hour 5, I'm going to double 48. So that's 88, 96. Okay. So what's happening every single time? I am doubling it. So what do I say? What do I say it is in words? Each time, each hour, I guess let's use what it says. Each hour, double the bacteria. All right, so just think about what's happening in this situation. So every hour, I go from whatever I have the one before, and I double it, and I double it, and I double it, and I double it, and so forth. All right, so now that I have a table, let me go ahead and plot a graph. I will come back to an equation in just a second. So let's plot the graph. So at 0, and if you can't see this, this goes 0, 1, 2, 3, 4, 5. All right, so let's graph this at 0. So this is my x, and this is my y. So when x is 0, so this is going to be hours in the bottom. When the hours are 0, I should be at 3. So this is 3 right here. And if you can't see, it's going up by 3. So this is 3, 6, 9, 12, and so forth. All right, so at 0, it's 3. At 1, it's 6. At 2, it's 12. So it's going to be right here. At 3, it's 24. At 4, it's 48, which is somewhere over here. And at 5, it's 96, which is, somewhere over there. So do your best to join the curve as best as you can. Okay. So what do you notice about an exponential function? So draw what I'm about to draw on the top of the page. An exponential function does this. It starts off really slow and then rapidly grows. Okay, that's what an exponential function does. And this is growth. All right, the reason this is called growth is because it's increasing. Obviously, if it was doing this, and actually you can go ahead and draw it. So it decreases really rapidly, then kind of tapers off. This is called decay. So it's decreasing, right? So 2 things that we're going to look at is an exponential function growing, or is it decay? Now that we have a graph, let's take a look at this equation. So equation-wise, you can see that right off of a formula sheet. So you will get this formula as always. And we're going to look for it. So we're used to looking at y equals mx plus b, which is a straight line, which is linear. We're also used to seeing y equals ax squared plus bx plus c, which is the standard form for quadratic. We've also looked at vertex and factored. Now we're on exponential functions, so I'm looking for something with exponential functions, and right here it says exponential formulas. So I've got an exponential equation which says y equals abx. So I'm going to write that down so I can explain to you what that means. So y equals a parentheses b and then x, and we're going to go through what that is. Now, as you can see, just like y equals mx plus b or the quadratic one, they don't tell you what each thing is. You have to learn what each of those things are. So I'm going to tell you what it is. So, and sometimes, and I'm going to put this in a different color, sometimes there's another letter here. We'll address that later. So right now, we're going to say if there's nothing there, it's always 0. So our C is 0. But your A plus C is your y-intercept. Your A plus C. So if there's nothing there, then what is the y-intercept? Just your A. So a lot of times, A is your y-intercept. The only time that changes is if they have another number after the parentheses. It's rare, but it does happen. All right, so your A is your y-intercept, or your A plus C is your y-intercept. Your B is your growth or your decay. How it is growing, growth or decay. So it's how it's growing if it's going up, how it's decaying if it's going down. All right, so let's start with the very first thing. So I'm just going to change my color here. So I'm going to write the equation for what is happening in our pattern up here. Okay, so I have y equals, and then I need to find out what a is. So what's a? My y-intercept. And what's another thing for y-intercept for those of us who are not in a math class? If you're explaining it to your mom, for example, you would say where you start. So where did I start? I started at hour 0, and what was my starting number of bacteria? 3. So that's my start. All right, so my start is 3. Then I'm going to put parentheses, and the question is, how am I growing or decaying? How am I increasing or decreasing? So what happens from one step to the other? How am I growing and how am I decreasing? I am doubling. How do I say double in math? I say times 2. So I'm doubling is going to be times 2. And then x, and I forgot to label what x is. X is time. Okay, x is time. So that's just going to be what it is. So this is how you write the equation. So let's answer a couple of questions now that we know how to write our equation from a pattern. You can also write an equation from your table. You can write an equation from a graph, and I'm going to show you all of that in just a second. Let's just talk about where do you see the numbers from this equation, okay? And I'm just going to add a couple of things so you can answer this. So from here to here, what am I doing? Multiplying by 2. Here to here, multiply 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 by 2. All right, so my question is, where do you see the numbers from the equation? So look right here. Okay, so looking at my equation right here, where do you see those numbers in this table? All right, so let's start with the number 3. Where do you see the number 3? Right here, right? And what can you tell me about that number? It's my y-intercept. So how do I find my y-intercept from a table? I go where x is equal to 0. So let's go ahead and write that down somewhere. So x is equal to 0, y-intercept. Okay. Where do I get this 2 from? So looking at my table, where do I get 2 from? Well, you can see I have 2's all over here, right? So true 2's are how it is growing. So it is my factor. If that's not something you're going to remember, we can write what you're multiplying by. So we can write B, and this is going to be equal to A. B is what multiplying each time. And that in math is called your factor. Okay, so my factor is times 2. And if you know that it's factored, that way we don't have to write what I'm multiplying each time, every single time. So I get B from my factor, what I am multiplying each time to get the next number. And I get A from my y-intercept, which is when x is equal to 0. So that's where I get the numbers from this equation. All right, now I'm going to look at another thing here. It says, I guess I should have answered this one first. What does 3 represent in the problem? All right, so now we got to write this in context. What does it represent in this problem? So I'm not going to say the y-intercept, because what does that mean? right? So you always have to write it in the context of the prompt. So it's my y-intercept. I know it's here. It's right here is my y-intercept when 0 and 3, but use these words to write it. So it is, and there's so many different ways as we've previously discussed that you can write this, but it is the amount of bacteria at the start, or the amount of bacteria at 0 time, the amount of bacteria when no time has passed. I think I like that one better. So what does it represent? The amount of bacteria when no time has passed. Okay, so what does it represent? It's what I'm starting with. So no time has passed because the hour is 0. This is what I start with, the amount of bacteria I start with when no time has passed. I even like that better, the amount of bacteria I start with. And that's what the y-intercept means. We've done this extensively. All right, number 3, where do you see the numbers of the equation from? It is supposed to say from, where do you see the numbers from the equation in the graph? I'll probably have that corrected by the time you guys get the sheet. All right, so where do you see the numbers in this equation? So I'm looking for these numbers 3, 2 now in the graph. So in other words, whether I was given a table or a graph, I need to know how to write this. And then I'm going to show you how to use a calculator as well. All right, so where do I see number 3? So I see number 3 right here, right? So that's my y-intercept. So we know from the graph, I'm going to say A is y-intercept where it crosses the y-axis. Okay, this way you know wherever it crosses the y-axis, that's your A. So whether I'm looking at the table when it's x is 0, I know how to find A from both the table and the graph. All right, then where do I see this number 2? So this one's a little bit more tricky because it's not very obvious. But going off the table, I know I'm multiplying by 2 to get to the next number, right? So it is how am I going from here to here? All right, so we can see I'm going to go up 3, from 3 to 6 is 3, and then I'm going to run 1. Then I'm going to go, remember each one of these boxes is 3, goes up in 3. So this is going to be 3, 6, so it's going to go up 6 this time and still run 1. Then I'm going to go, this is 3, 6, 9, 12, and then I'm going to run how many? 1. So what's the pattern that I'm doing each time? And you can see, what am I doing? I am multiplying by 2. From 3 to 6 to 12, I am multiplying by 2. So from the graph, if you want to find the rate of change, okay, what you're going to do is take the second point and let's see, B. So B is going to be, take your second point, let me say Y, okay, then divide by your first point. Both Y on the Y values, okay? So I have my second one is 6 divided by 3, and it works for any. So 6 divided by 3, or I could have done 12 divided by 6. And if you put all of that in the calculator, 6 divided by 3 is 2, 12 divided by 6 is still 2. So it doesn't matter which one it is, but the points have to be consecutive. In other words, the distance from one point to the other have to be the same, okay? So find your second point divided by your first point, or you can draw it out if you want to, whatever is easier. Okay, I'm also going to show you how to do this in the calculator. But before I show you how to do it in the calculator, I do want you to be able to do it by hand. So actually, you're going to pause the video and complete example, the second one. All right, so go ahead and pause the video, and you can work together in groups, but I want this completed, and then you're going to give it to me to grade. Let's practice.